Welcome back, everyone. It's time for another episode of A to Z of Python. Today we'll be talking about the letter Q, which will represent the queue, and something called a deque, which is essentially a double-ended queue. And so let's just get right into it. The first thing that we're going to do is import the queue, and then we'll start constructing them. Now, when you make a queue, you can think of it as a list that can kind of grow and shrink, and you can add items into one side and you can pull them back out, and it helps you keep track of things. And there are two different types of queues. There's one called FIFO and one called LIFO, and the first one is first in, first out, and then there's last in, first out. And if you're not familiar with that, it's just one is pulled off in the order that they're put in, and the other one is pulled off basically in the opposite. So let me just show you what that looks like, and it'll make perfect sense. So the first thing that we need to do is to go in and start our queue. So it'll be q equals q dot q. Say q a lot of times in this video, by the way. And then we're going to do for I in range 5. And we'll use the put method, so q.put, and we'll use I. So you can imagine here, if you use your intuition, that we're going to just take the numbers 0 through 4, and we're going to put them in to this queue here, and that's it. So once that's done, we can use the empty method to iterate over it until it's basically empty. So we'll do while not q.empty, and we'll print it out. So do q.get, and there you go. So you've seen put, which puts elements into the queue, empty, which checks if the queue is empty or not, and get, which actually does two things. It returns the value, the first value if it's FIFO, or the last value if it's LIFO, and then it also removes that value from the queue. So the get actually does two different things. So if we go ahead and we run this, we get 0 through 4. Okay, so first in, first out. So it goes in through this loop 0, 1, 2, 3, 4, and that's the way it comes out. Now we can change this to a LIFO queue just by changing this part right here, and all the rest of the logic stays exactly the same. So what we could expect here is the LIFO queue will put the things in the same order, but it will take them out in the opposite order. And so if we add the queue as 0, 1, 2, 3, 4, we should expect the LIFO implementation to go 4, 3, 2, 1, 0 when it prints them out. There you go. So if we run that, it works exactly like you would think. So it's really just like a fancy list that has some sort of arguments that you can specify when you create it. And there's some things you can pass in here that will limit like the size and maximum size and things like that. But not really probably something that you need to worry about too much right now. So that's like pretty much it for those two parts. Very simple implementation, and pretty useful actually. So now that we've got those, there's another one that's a little more complex, which is called a priority queue. And the priority queue is similar in the sense that it's like a queue that you can just add stuff in, take stuff out, but it allows you to add some sort of numerical importance to each task that you add to the queue. So we can say, hey, this is high importance or low importance, and it'll go through and it'll pull them out in order that you tell it to. So let's do an example. We'll do pq equals q.priority queue. So again, the queue construction is very much the same. It's just we're specifying the queue type by calling up that method. So pq, and let's manually put the information in this time instead of running a loop. So we'll just do pq equals, or just do pq actually dot put. And In here, we need to put a couple of things. Um, well, you can put just an item if you want, like it's saying here, but generally it's nice to put a tuple in there that contains a number and a list item. So if we put another set of parentheses, I can say, priority 10, and I could say mow the yard, right? So this is an example of a tuple being passed in or put into a priority queue. And the way that Python will interpret this is that the number 10 is the importance level, and this is the task. And number 1 is the top priority, and bigger numbers become a lower priority. So the first thing is like the biggest. So if we do pq.put and we put something in at number 1, something that's very, very important, we could say like drink beer. It's like we're going to procrastinate off mowing this yard. And then if we drink some beer, we may also want to say order pizza. So here we have drink beer as the number 1 priority, order pizza as the number 2 priority, and mow yard as the number 3 priority. And it's the third priority because it's the third item here out of 3. But if we were to add more, things that were greater than 10 would come in last, and things that were less than 10 would come in before mow yard. So hopefully that makes sense to you. So how would we go about this? Well, let's just try it out. We'll do the same thing. While not pq.empty, I'll print pq.get, and it's going to get this tuple here, and I don't really want the index here or the priority ranking. I just want the actual task. So we can just use the index 1. So this is 0, this is 1, and we can print that out. There you go. So we run that and we see that it says drink beer, order pizza, mow yard, and it's got the order correct. And that's pretty much all there is to it. Now if you wanted to print out the queue, it's not really natively supported, and that's a bit of a problem with the queue itself. Like in order to see what items are in the queue, you have to actually get them, and the get, as you recall, returns and removes the item from the queue. So by getting the item to print, you're actually popping it off the queue, and that's not good. So there is a workaround, and it essentially involves creating a copy of the queue and then making that a list and then iterating over that. Not something that I don't think is recommended, but it can work. So you can just do for I in list pq.queue, which will spawn off another copy of that, and we can just do the same thing, print like I, and that should give us, yeah, there you go. So there's all the items there, each individual element as a tuple. And that's not technically thread safe, but whatever. So you can get a printout if you need to. That's how it's done. So that's pretty cool. You can also use threading if you have a very large queue that you need to split up into multiple threads to prevent, say, one execution that's taking too long from holding up everything. And that's kind of common if you're doing like reading from a server somewhere that may have latency issues or something like that, and maybe you're scraping a website and the site is slow to respond. You wouldn't want all the other sites to stop just because one of them's taking too long. So if you thread them out, you will give the CPU the ability to kind of toggle between, say, 3 or 4 or 10 or whatever, however many threads you create. It can toggle between those functions and divvy the time up to where they get executed in the fastest way possible. So in order to do that, you would import threading. And I'm going to just copy and paste this in because it's not really what I want to talk about, but it is kind of cool. So if you've seen the multi-threading video, this will make sense. So we need to also import random. And essentially what you do, just to kind of gloss over this, and you can pause this if you actually want this code or it's pretty sure I took this straight from the Python documentation, so it's like easy to get there too. But you have a worker function that runs while true, get items out of the queue until it's empty, and then it breaks out, and then it returns task done, which lets the queue know that that you're finished with that. It can go on to the next one. And we create the queue just like normal, standard FIFO queue. We create our thread list. I've generated a list of a bunch of random numbers, okay, and like 1 to 1,000, and it's like a whole bunch of them. And let's see, I printed out those just so you could see, and that's not really totally necessary. And here what we've done is we've created the threads. So this would be actually the amount of threads that you want. So it chose 4 threads. It's going to create a thread with the target being the worker. So each thread will continue pulling items out of the queue until it's done, and then it will mark it that way. And we'll start the thread, append it in there, and there you go. So the rest of this is just kind of clean up for the threading. You do the join and wrap everything up. But essentially, if we run this, what we'll see are thousands of random numbers output, and those are actually being output or printed here four at a time, if that makes sense. So you have 4 individual threads pulling items out of the queue and printing them out, and it's probably more or less in order of the actual original list. So these numbers are in order that they were generated, but it doesn't always turn out that way. So if you're using a priority list, for example, and you care what order they're executed in, and you have a bunch of threads and one thread gets hung up, it's going to execute them in the order that the other threads are available. So you might find that priority queues, when threaded, don't always meet the exact explicit priority. If you look at the list as a whole, it might meet the priority of the list in chunks, which is just fine. So still better than having a particular task tie up your system while you could be doing something else. So that's an example of threading. I don't know if it really matters that much. That's why I'm kind of just going over it, but it is there if you decide you want to do it. So next we have what's called the deque, and to do that we import something called collections, and that's where the deque function actually resides. And we're going to do a couple of things here, and I'm going to start by showing you how it works. So we'll just call this deque. You could call it Q or whatever you want, or give it an actual descriptive name. And I'll do collections.deque, and we need to give it some sort of iterable, and that means it could be a string literal, it could be a list of numbers. So we'll start there. So let's do 1, 2, 3, 4, 5. And this is a double-ended queue, which means we can add or remove data to either side. It doesn't have to be necessarily a FIFO or a LIFO queue. It can sort of be whatever you want, whenever you want it to be, which is pretty sweet. So we'll do print deque, run this, and that's a deque with an iterable inside of it. I can also do, let's just change this here to a string literal and run that, and you see that it does the same thing. It essentially takes each item, iterates over the string, and breaks each individual item into its own index. So we have a list of characters at this point, which is cool. So that works. We can iterate over it. So for I and deque, print I, that works just fine. Okay, so it's functioning a lot like a list at this point. And it's got a bunch of methods that you can use. So let's talk about those. So we can do count the number of times something exists. So like print deque.count. Let's search for A and get a 1. Let's get rid of this. There you go. So we get rid of that too. Sorry, I'm trying to clean up this output. There you go. So you get a 1. And if we add another A in there, we get a 2. Okay, so we can search for the amount of times any particular thing exists in a queue. That's pretty cool. We can extend this out so we can add things to it and extend. So we do deque.extend. This will add things to the right side of the queue. And so each time you do something, it has to happen on either the left or the right because it's a double-ended queue here. So let's add some numbers to the right side and print that out. Alright, so you see, let's get rid of that. Let's just make them 5. 1, 2, 3, 4. Okay, so there you go. So A, B, C, D, E, 1, 2, 3, 4, 5. And you notice that these are strings and these are integers and they're coexisting just fine, which is pretty sweet. So that's how you would add things to the right. Okay, you can add things to the left. We could do deque.extend left. And maybe I want to put in some special characters and I want to print that out. There you go. So now you can see it's added these to the left because we did extend left, and it's added these to the right because we did extend right. So that's pretty cool. What else can we do? We can insert an item at a specific index, which is really neat. So we can do deque.insert, and let's just put something in the 5th place and make it say 5th place, and print out the deck again, and you'll notice in the 5th index it's got something called 5th place. Okay, so that's really cool. What else can we do? I'm just kind of going to go through these, run through these really quick for you so you can see what the deck can do. We can get the index of the first match of something, so that might be cool. So we could print deque.index and we'll search for like B, and we'll run that and we get 7. So B is in index 7. And we can also specify a start and a stop index. So if we did 5 to 10, okay, it finds it. If we do 0 to say 4, which we know does not contain that, we'll get a type error, or a value error, excuse me, that it's not in there. So if you want to search for a particular item through a certain range, you can do that. Otherwise, you can leave this blank and it will search over the entire queue. Okay, so that's nifty. What else do we have? We got reverse. So let's get rid of this stuff and we'll print this out. And then we'll do reverse and run this. And you can see we went from ABCDE to EDCBA, so the reverse works just fine. We can also pop and pop left. So if we do, let's make this 1, 2, 3, and we'll do deque.pop. And we will print that. Let's print that. So the deque.pop is like a get. It gets the item. So in this case, it'll take the 3 out, and it will let you do whatever you want with it. It returns it and removes it. Okay. So if we do that, we get a 3, and then we can print deque again, and we'll see that the 3 is now gone. Alright, and then we can do, let's see, print deque.popLeft if we want to get rid of the 1, so we can go from the right here or the left here. Okay, so pop takes the item from here, and pop left takes the item from the left side, and now all we have left is the 2. So we have a queue with just the number 2 in it, and we can also do .remove, and we can search for something specific to remove. So in this case I'll do 2, and okay, and I'll just print deque, and it's empty now. Alright, so these are actually strings here because I just did it as characters, but you could do it as integers as well. Doesn't matter, just make it a list containing integers. So remove, and I think that is almost it. Oh yeah, there's actually a let's get rid of this, and we'll do something with some symbols in it to show you what's called rotate. And we can do, so print that out, and then we'll print or we'll do deque.rotate 1 and print that out. Alright, so you see the stars in the middle, and then we rotate it once and the stars on the right. So rotating it with a positive integer will move everything to the right that many numbers, and if we do it with a negative, so if I change this to a negative and we run it, it moves everything to the left, and so when it drops out it just gets moved and appended over to the back. Okay, so it doesn't get rid of anything, it just rotates them around. So you can go to the right or to the left if you use a positive or a negative integer, and that does have some pretty neat things that you can do with it. And if we look at the Python docs, we can see creating a moving average using iter tools and popping out items, and then we also see a way to use slicing and deletion, and this is just essentially rotating the item up and popping it out. So if you wanted to get rid of a particular item, you can kind of rotate, pop, rotate it back. And so there's a couple of different functions that they have shown here as examples for the deck. And otherwise, that's about all I have to say about that. So queues and deques, pretty cool. Hopefully you'll find a use for them, and I hope that you learned something on this video. Thanks for tuning in.